Okay, now that we've talked about the different types of fractions and some vocabulary, we need to remember that when we're dealing with fractions, we always have to write fractions in lowest terms. That is just a must. We never ever leave fractions in a form that they can't be reduced down, or that they could be reduced down, I should say. Okay, now before we do that, we need to pick up just a little bit of review again of some vocabulary. When we talk about multiplication, remember that we have specific words for each of the objects there. For instance, if I say 4 times 5 equals 20, the 4 and the 5 are called factors. Things that are being multiplied together are called factors. And the answer to the multiplication problem is called the product. Now, there are some numbers, or some products, I guess you could say, that have a lot of factors. Some don't. There are two different types of numbers. Numbers are either prime or they're composite. Now, there's only, well, one is not considered prime or composite. It's neither, but it's a kind of a weird case. Prime numbers are defined as they have factors only of 1 and their self. So, for instance, a number like 5. 5 is a prime number because you can't break it down any further. The only things you can multiply together to get 5 are 1 times 5. That's it, nothing else. So because that is true, then this fits the definition of a prime number. It has only factors of 1 and itself. Now, composite numbers would be everything else. They have many different factors. So say, for instance, the number 10. 10 is a composite number because we could multiply 1 times 10, or we could multiply 2 times 5. So it has factors other than 1 in itself. This is a composite number. Now, all numbers can be written as what's called product of primes. Now, if you think about what this means, product would be a multiplication problem, the answer to a multiplication problem. Primes would be numbers that have only 1 in itself as factors. So let's look at this number 90 here. 90 is a composite number because you could multiply 1 times 90, but there are other things you could multiply also to get 90. In order to try and write it as a product of primes, we would have to do what's called the prime factorization tree. So let's think of two things that multiply together to get 90. Maybe 9 times 10. And it can be anything you want as long as it multiplies together to get 90. Now we look at each one of these little stemmed off parts. 9 is not a prime number because we can think of two things that multiply together to get 9. And that would be 3 times 3. Now 3 is a prime number, and 3 also is a prime number, so we can't break these numbers down any further. They're prime. But 10, we can break it down further. It's a composite number. 2 times 5 would give us 10, and 2 is a prime number. Only 1 times 2 will multiply together to get 2, and 5 is a prime number. So now what we have is, if we were to multiply all of these things together, we would get 90. 3 times 3 would be 9, times 2 would be 18, times 5 would be 90. This is writing a number as its product of primes. Now when we do this, we always want to make sure that we write it out smallest to largest. So the proper way of writing this multiplication would be 2 times 3 times 3 times 5, so that we're listing them in order from smallest to largest.